Okay, so today's warm-up is certainly the most complicated one that we've done so far, but once we break it down, I'm sure you'll see that it really isn't that difficult at all, just lengthy. The other thing that you'll notice is that there are two ways to solve this. Some of you took one approach and others took another, so I'm actually going to solve this problem both ways. So you really should take the time to watch both ways so that you understand what happens and the fact that you can solve many of these in more than one way. Okay, so first of all, some students are making treats for a math party, of course. The thing we have to do when we're writing expressions is to find out what the thing is that we don't know first, or what's the first thing we need to know to figure out everything else. So let's analyze this. Amelia makes twice as many cupcakes as the number of cookies that Jada makes. Jada makes 1 dozen more than Emma. And then it tells us about Corbin making cake and Matt making 2 pies. So those are constants. We don't need to write any kind of expressions for those because they just are what they are. So we're going to leave Corbin and Matt's number treats aside for now and focus on Amelia, Jada, and Emma. So who's the first person we need to know in order to solve any of these? Amelia's depends on Jada's, and Jada's depends on Emma's. So the first person we should be starting with is Emma. So I'm going to write my first let statement. Let x equal number of, what is Emma bringing? Cookies. Emma brings, or makes. Yay, homemade goodies. I can't wait for this math party. That's the next. So Jada makes 1 dozen more. More tells us that it's addition. 1 dozen tells us that it's 12 more. So we're going to say let 12 more than x would be x plus 12 equal the number of cookies that Jada makes and then finally we get to Amelia. Amelia makes twice as many, well twice means we're multiplying by 2, twice as many cupcakes as the number of cookies that Jada makes. Well, we know that Jada makes x plus 12. We know we're multiplying that times 2. So we need to be careful here because the thing that happens first is x plus 12. So that tells us that the x plus 12 needs to go in parentheses. So we'll have 2 times the quantity of x plus 12 equal the number of cupcakes Amelia makes. Okay, so this tells us we have to write 4 expressions. 4 expressions. Well, what other information is it that we need to focus on? We know that Corbin makes a cake, Matt makes 2 pies. That's not something that we don't know, so we don't need to write an expression for it. And we're given this last piece of information. All together. All together indicates that it's a total we're looking for. A total. So that means I need to add them all together. So let's add each of them together in my final let statement. I'm going to have x, that's how many Emma made, plus x plus 12, that's how many Jada made, plus 2 times the quantity of x plus 12. And I can't, I changed up the color. Let me fix that so that it's just all uniform. Don't want to confuse anybody. So let me get back to yellow. So this should be plus 2 times the quantity of x plus 12. And now I can't forget that Corbin makes a cake. So that's plus 1. And that Matt makes 2 pies. So that's plus 2. So I now have included everything for each person. So that's going to equal the total number of treats. Now, some people are inclined to write the word treats down here, but that will just get it confusing, so please don't do that. Try and keep all of your words together after the equal signs. Even if you have to go to a second line like I did, keep it down there underneath the equal sign instead of under our expressions. It does get confusing that way. So, part 1 was to write my series of 4 expressions. I have now done that. So I believe the next part is going to be when I'm solving my equation. There it is, solve the equation. So I have to rewrite part of the equation. Remember, my equation is always total. I don't know what's wrong with my stylus here. Total. I may need to switch. Total equals total. Total is always equal to total. So that means I've got 2 totals here. Well, I sure do. I have the first total, which is the expression that we wrote. So that, of course, is x plus 12 plus 2 times the quantity of x plus 12 plus 1 plus 2 equals the total that they gave us, which was 167. Now, some of you might have been inclined to write that 1 plus 2 already as plus 3, but I really want to be sure that each step is very, very clear. Now, we know that we need to combine like terms. We need to put all of our x's together, all of our numbers together. But before we do that, we need to notice that right here is something that needs to be solved first, that like inside parentheses, well, we can't do anything to the x plus 12 because x and 12 don't go together. However, we can, what we need to do is send in that 2. In other words, apply the distributive property. So sending the 2 in, here we go. Woo! Woo! Isn't that fun? So that's 2 times x plus 2 times 12. And I am ignoring the rest of this for right now. 2 times x is 2x. Bring down the 2. 2 times 12 is 24. And now I bring down the rest of my problem. Plus 1 plus 2. I'm ignoring what's on the other side of the equal sign, just temporarily. X plus 12 plus my new part of the expression here. So now, of course, I am going to continue combining like terms. I'm going to box and underline the things that are the same. So I've got variable, variable, and don't forget to bring that operation that's in front of it, because otherwise we don't know if we're adding or subtracting. In this case, it looks like it's all addition, but sometimes there is subtraction, as you'll see in our next example. So I've got plus 12, which does not have a variable, so I'm underlining it, plus 2x, plus 24, plus 1, plus 2. So I'm going to rearrange this to make it easier to look at. So I've got x plus 2x. That's everything inside a box. I'll keep that boxed in. Plus 12 plus 24. Whoa, where did I get my 12 from? Sorry, I was looking above. I apologize for that. Oh, no, I wasn't. I'm just confusing you. So plus 12 is right here. Plus 12 plus 24 plus 1 plus 2. And those are all my constants that need to be added together. So here I've got x plus x. Well, that, of course, is 2 x's plus 2 more x's. 2x plus 2x is 4x. Got 12 plus 24 is 36. Plus 1 plus 2. Remember, I can only do this if I'm adding. 1 plus 2 is 3. 36 plus 3, of course, is plus 39, still equal to 167. So I now need to solve this. Just like always, I ask the question, what's the opposite? What's the opposite of plus 39? Of course, is minus 39. Whatever I do on one side, I need to do on the other. These cancel. I'm left with 4x equals 167 minus 39. Well, 167 minus 40 would be 127, but it's not 40, it's 39, so therefore it would be 128. I ask myself, what's the opposite? The opposite, of course, of multiplying by 4 is to divide by 4, both sides. And, of course, I have to come over here. These cancel. Remember, 4 divided by 4 is 1, or that 1x. The 1 is invisible. So I've got x equals 128 divided by 4. 4 goes into that 12 3 times. 4 goes into that 8 2 times. So I've got x equals 32. Well, now I still have to figure out how many treats everyone brought. So I need to take this, and here we go. So I know that Emma, I'll start with Emma, because that's who we started with. Emma, the expression for Emma was x, semicolon. We now know that x equals 32. So that means that Emma brought 32 cookies. The next person is Jada. The expression for Jada was x plus 12, semicolon to separate both parts. Not C. C, I was thinking cookies and cupcakes, but I used x as my variable. Or you can always use whatever variable you want. And x will equal still 32. I substitute in 32 plus 12. 32 plus 10 is 42, plus 2 more is 44. And Jada, again, brought cookies. The next person is Amelia. The expression for Amelia is 2 times the quantity of x plus 12, semicolon, x equals 32. Substitute in, becomes 2 times the quantity of 32 plus 12. 32 plus 10, well, and again, inside parentheses first. 32 plus 10 will be 42, plus 2 more is 44. That's still going to be multiplied times 2. That, of course, is 88. Amelia brings 88 cupcakes. Oh, boy, I can't wait for those. And then we should include that, even though it was given information, that Corbin brings 1 cake and Matt brings 2 pies. We are going to have quite the math party here. Okay, as I pointed out in the beginning of this, there were in fact 2 ways to solve this. Next, let's take a look at the same problem again. And what many of you did was, instead of starting with Emma, you decided the first person we didn't know was Jada. I believe you did that because you only read the first piece of given information and didn't read beyond that before you decided what you didn't know first. So it's fine, we can still make this work. So my first let statement, I'm going to say let, I'm going to use a different variable. Last time I used x. I'm going to use n this time. So I reversed it. I should say let n equal the number of cookies Jada brought. Or Jada makes. So we started with Jada. Amelia makes twice what Jada makes. So twice means to multiply, so that would mean let 2n equal the number of cookies Amelia makes. Oh no, Amelia didn't make cookies. Amelia made us cupcakes. I almost forgotten. You know they all make some sort of yummy treats for our math party, but I want to make sure that we identify the right things. I don't want to confuse anybody. So, number of cupcakes Amelia makes. I know that some of you just simply wrote treats. That's fine too. But again, I'm trying to be very, very specific. Next person is Jada. Jada makes 1 dozen more than Emma. Now, this is the place where it becomes a little bit more confusing if you're not very careful here. Jada makes 1 dozen more. Jada makes 12 more than Emma. So let's think about this. Does that mean that is whatever Emma makes plus 12 or what Jada makes plus 12? Because it does give me more, but then the thing that I'm starting with is Jada. I've got N first. So what am I going to do? If I know that Emma is 10, oh, no, wait a second. I know I'm starting with Jada, not Emma, because that's what I have here, is that I'm starting with Jada. So Jada is N, and she's making 1 dozen more than Emma. That means to figure out how many Emma made, I need to subtract, which seems counterintuitive to seeing the word more, but you really need to analyze these statements. So here we're going to say let N minus 12 equal the number of cookies Emma makes. Okay. And now, of course, we've got that final altogether, again, the total. So just like before, I'm going to add up each number. Right now it's an expression of how many cookies each person makes. So I'm going to start with Jada. Jada makes N. Oops, I forgot my let statement. Let N plus 2N, that's how many Amelia makes, plus N minus 12, that's how many Emma makes, plus Corbin makes 1 cake, plus 2 pies that Matt's going to make. And that equals the total number of treats. Okay, so I'm going to carry that on to the back because I'm going to be rewriting this on the back, or on the next page, of course, is what I mean, in order to solve this equation. Now, my equation is going to look different. Remember, it's x plus 2x plus x minus 12 plus 1 for Corbin, 2 for Matt. That's my first total, the expression I wrote, equal to the total that we were given, 167. I know right now some of you are confused because this looks a lot different than the last one, but follow it through because you'll see that we're going to end up in the same exact place. Now, I do want to box and underline here to separate the things that are the same. Well, that's convenient. They're already in order for me. They're not always like that. So x plus 2x is 3x plus another x. 3x plus 1 more x, that gives me 4 x's, or 4x. Now be very careful here. I've got negative 12 minus 1. A lot of you are going to want to ignore that negative, and it's going to make a mess of what you want to do. Negative 12 plus 1. Signs are different. Find the difference. So we're going to have 12 minus 1. 12 minus 1, which of course is 11. The larger absolute value is 12, so that makes it negative 11 plus 2 more. Negative 11 plus 2. Signs are different. Find the difference again. So that's going to be 11 minus 2, which is 9. And again, it's going to be negative because negative 11 has a larger absolute value than positive 2. I'm going to bring down the rest of the problem. I've now got 4x minus 9 equals 167. Now I solved this the way I solved the other ones. Ask myself that same question. What is the opposite? What's the opposite of minus 9? Is plus 9 on both sides. Minus 9 plus 9 cancel out. I'm left with 4x equals 167 plus 9 more. Well, if it was plus 10, it would be 177, but it's 1 less than that, so it's 176. What's the opposite of times 4? Well, that, of course, is divide by 4, both sides. These cancel out. I'm left with x equals 176 divided by 4. So 4 goes into 17 4 times with 1 left over, and 4 goes into 16 4 times. So I now have found that x equals 44. However, I still need to find how many each person makes. So, next page, Remember, we started with Jada this time. So again, I'm still going to start with Jada. So the expression for Jada was simply x. I need a semicolon to separate the two parts. I found that x is equal to 44. That's 44 cookies. If you look back, this is the same answer we got for Jada before. Next was Amelia. The expression for how many Amelia brought was 2x. Oh my gosh, did I change them over to x's on us? I am so sorry. I just realized I did that. I'm not going to go back and change them all. You can either use n's all the way through or x's all the way through. I do apologize. It doesn't matter what the variable is. Obviously, it shouldn't have changed halfway through. So you need to go back and either change all your x's to n's or change all your n's to x's. I actually, right now, am going to change these to n's because that is what I started with. But I'm only going to do that on this page. Quite honestly, the way this works, if I go back to another page, it will mess this up. I've now learned that that's the case. So I am going to make them n on the final page. I apologize for what I might have done on the previous page. So a semicolon to separate them. N is still equal to 44. 2 times 44 is 88 cupcakes, which is exactly what we got last time. And then we have Emma. Emma, the expression for what Emma made was x minus 12. A semicolon to separate the two parts. X equals 44. I've got 44 minus 12. Well, if I have 44 minus 10, that would be 34. Minus 2 more gives me 32 cookies, exactly what we had last time. So you can see how it really doesn't matter where we start. We will still end up with the same answers. I am including how many Corbin and Matt gave, even though that was a given, just so that they're all together on our final page. And there you go.